All right. Welcome, everyone. This is Predicting the Future of Web Development. I'm Richard Feldman. Let's start with a question. Have you ever gotten to choose your stack at work? Like your greenfield project, it's totally up to you, or maybe the team that you're working on, you get to pick what front-end stack you're working with. Okay, yeah, me too. So I've also been in that position. The first time I was in that position was all the way back in 2006. This was the first web app that I'd ever worked on. And there were 4 of us. It was a startup. And at the time, the thing that was big in web apps, and this is sort of the dawn of web apps, was the LAMP stack. Anyone ever remember the LAMP stack? Okay, yeah, Linux, Apache, MySQL, and then the P was overloaded to be PHP, Perl, and Python. And the reason that P was so important was because basically we did all of the rendering on the server. We would generate HTML on the fly and then send it to the browser on every page load. And so this is our first time building a web app, and we're like, okay, what do we do? Well, one way you can choose your tech stack is there's an old saying that goes, choose boring technology. Essentially, try to pick something that is mature and established and used by a lot of people. So here's one example of a 2006 boring technology. This is what we ended up going with. It was the #1 biggest library ecosystem at the time. It was the most mature option in the LAMP stack by a considerable margin. It was used by successful companies, including the social networking giant of the day, LiveJournal. And so we chose this technology using this methodology, and this is how we ended up building our entire startup on Perl. So since 2006, Perl's popularity has not been the best. This is the Google trends for like Perl searches since 2006, and kind of the lesson here is that just choosing boring technology is not a guarantee of safety. This doesn't mean that everything's going to be okay as long as you just do what everyone else is doing right now. You kind of have to look towards the future and try to figure out, like, how are things going to go in the future? The other lesson here is that it's not necessarily a problem that Perl declined in popularity. The problem is that if we were trying to hire right now, there's not a lot of people who want to do Perl development these days. There's not a lot of ecosystem support compared to what there used to be back then. So it's not necessarily a problem if something is small, but it is a problem if people are losing interest in the technology and just don't really want to use it anymore. So any technology that we choose, no matter how popular, how mainstream, how much traction it's got today, is still making a bet on the future. There's no safe option here. It's just a matter of what do we think is going to happen. The real question, I think, is any technology choice we're making today, are we still going to be happy with that in 5, 10 years? So predicting is safer than following blindly. Like following the herd and just trying to do what everybody else is doing is not as safe a bet, I think, as trying to predict like what actually is going to happen in the future and then follow that instead. So I'm going to be making some predictions today, some concrete predictions. I'm going to make some predictions about what I think is going to be true about web development at the end of 2020 and then also at the end of 2025. So I'm going to break this down into 4 areas. 1 is TypeScript, 2 is WebAssembly, packages, and finally compile to JS landscape. So let's start with TypeScript. More like HypeScript, am I right? I mean, come on. We saw Matthew's talk yesterday about this graph of like TypeScript's, Google Trends are like the opposite of Perl's. It's like really taking off. A lot of people are talking about it. Not even going to bother explaining what it is because you've probably all heard of it. He also drew the comparison of TypeScript and CoffeeScript. Like a lot of people have said, like, well, is TypeScript just going to turn out like CoffeeScript? What is in the future for TypeScript? Everybody's talking about it now, but are they still going to be talking about it and using it in a few years, or is it going to end up tapering off the way that CoffeeScript did? Well, 2 things to note about this. One is that obviously TypeScript has already grown way beyond what CoffeeScript did in terms of interest, if Google searches are any indication. And secondly, that its trend is still going upwards. So we haven't really seen any indication that TypeScript is slowing down. So what do we think it's actually going to do? Well, obviously, frameworks are all on board. I mean, this was certainly not true of CoffeeScript. Like, no matter what, you can't really throw a stone without hitting some framework that's either got first-class TypeScript support or is working on adding it already. But despite this, the fact that there are so many people in the ecosystem getting on board, not 100% of people are on board. There are some things that people don't like about TypeScript. For example, I saw one tweet that was complaining about having to deal with this type. I'm not going to read this whole thing out because I have a limited amount of time to give this talk. But obviously, like encountering this on a daily basis is not super pleasant. This is kind of a really verbose, like kind of difficult to understand thing. There's probably some Java programmers who are now looking on and being like, you all made fun of us with our abstract singleton factory proxy bean. Who's laughing now? David Nolan yesterday said that maybe TypeScript is kind of like enterprise JavaScript, and I think there's some truth to that. Another thing that people say they don't necessarily like about TypeScript is that although it gives you like more type checking and some degree of type safety, by design the type system is unsound and it can let things slip through to give you a false sense of security. One notable example of this being any, which is essentially means, oh, this type might be anything, who knows, we're just going to find out, which appears 4 times in this type signature alone. So there are definitely some things to like about TypeScript, but I think the most important factor to try and predict what is the future of TypeScript is looking at how it's impacting teams. I hear a lot of teams saying we are trying TypeScript, or we have used TypeScript, or we are using TypeScript. I hear almost no teams saying we tried TypeScript and then we went back to JavaScript. Actually, I haven't heard of any. I just don't want to get well actually like after this talk. So I'm going to say, yeah, it could theoretically happen. But personally, I actually have not heard of a single team, I'm sure somebody has, that went TypeScript and then went back. So it's basically a ratchet. Like people switch to it and then they don't switch back. And that means that it's going to continue to have more and more growth as long as that's true. That's a really powerful force multiplier. So essentially, I mean, there's a lot of truth, I think, to this tweet. Like, you know, maybe if an individual on a team is like, I don't like TypeScript, but if the whole team ends up adopting TypeScript anyway because that's what the team lead says we're going with, that's what the technical decision is, or maybe the department says we're going with that, and so every team has to get on board, whether or not individuals like it doesn't necessarily mean that that's going to change the fact that the whole team adopted it. So based on this, I think TypeScript's popularity is like just getting started. I actually think that, well, I'm going to go on record and say I predict that TypeScript ends up basically taking over the JS world, and I'll be specific about what I mean about that. So I think by the end of 2020, I think that for commercial projects, it's going to be the most common choice that teams make for a new project. Like if they're in that situation making a greenfield choice, they're going to go TypeScript rather than JavaScript. And I think by the end of 2025, there will be more people on a daily basis writing TypeScript than JavaScript without TypeScript. We'll see if I'm right, but I think that's where things are headed. Part 2, WebAssembly. Lynn Clark is one of the great explainers of our time, and she's done a great job explaining WebAssembly, so I'm not going to go into super much depth on that. Instead, I'm going to oversimplify what WebAssembly is as it's a way to run almost machine code in the browser. And the upshot of this is that essentially it lets you build applications that can run much faster than JavaScript. Now, one possible use for WebAssembly is you can use it to improve the perf of existing JavaScript apps and libraries and stuff. So one example that Lynn gave was you could use this to make the React reconciler faster, just speed up that one part of the library. I think that's interesting, but at the end of the day, I don't personally think that's like how WebAssembly is going to get used the most or the biggest impact that it's going to have. And the main reason I think that is I think that the existing status quo of JavaScript performance is pretty widely accepted as like fine. The reason I believe this is in part that I'm on the Elm core team, and a few years ago we had like a really exciting release, or so we thought, that was like, hey, look how much faster we made Elm. Like now it like renders faster than like React and Angular and Vue and Ember, like all these things. Look at how great these numbers are. And people were like, okay, but like, you know, like all the other things are fast enough, so whatever. I mean, good job, but you know. I think people are pretty okay with the status quo, and so if the pitch of WebAssembly is it's like, use the same technologies, but they'll be a bit faster, I don't think that's going to be enough. I think it's much more interesting for companies like Figma, and they wrote a blog post actually about how big a deal WebAssembly was for them. So Figma is a company that makes graphics editing software. Like their competitors are things like Photoshop and Sketch, and they're making a really, really serious, like heavyweight app. And this application is all built in C++. Like they did not build this Photoshop competitor using HTML, CSS, JavaScript. They built it with C++. That's what their team looks like. If you're going to work at Figma on this product, you're writing C++ all day. So essentially what they've built is a native application that happens to be distributed in the browser. They're not really using web technologies. If they attended this conference, most of what we talked about would not necessarily be of much use to anyone building this thing in the actual application. So essentially, I think that the main thing that WebAssembly is going to do in the future is it's going to allow browsers to compete with app stores and installers. Like the reason that Figma chooses to build their thing in the browser, I assume, is the fact that in order for people to use it, they can just go to a URL and immediately they're using it. They don't have to install it, they don't have to accept permissions, they don't have to go to an app store, none of that stuff. It's very low commitment, a very easy way to get in. Also, it is a great sharing story. If you're like in the middle of editing something and you want to send someone else a link to be like exactly on the same page as you are, and like they can just bring it up in their browser, that's also really easy in browser. So there's a lot of good reasons that people might want to distribute what is fundamentally a native app in the browser instead of using an app store or an installer. Now, another thing that's true about native apps is they tend to be pretty big in size. Like multi-megabyte downloads are kind of a normal thing for native apps. Like, yeah, Photoshop's like pretty big, of course, you know, that's what people expect. Not so much for web apps. We hear about like the bloat crisis, and we're talking about like kilobytes. And if your payload is multiple megabytes, it's like, what are you even doing? But But again, this is a thing where I think that people, tolerate this, like the status quo. Another experience we had on the Elm team was like releasing this thing where Elm's package, like bundled up size, got really small, thanks to like some really aggressive dead code elimination. And this is like not just the baseline size; it's like across the entire app. So we had this real-world app, which is basically a bigger version of To-Do MVC. So they have implementations in React and Angular and Vue and all these things. And the Elm one, after this new release, went down all the way down to 29 kilobytes for the entire 4,000 line of code single-page app. And React itself is like 35 kilobytes. We're like, this is amazing. Look how tiny this is. Everyone's talking about this bloat crisis, right? It's a really big deal. And people are like, I mean, good job. That's well done. But at the end of the day, people put up with the multi-megabyte downloads. I mean, I know like there's a lot of talk about this stuff, but there's way more talk than action. And we all kind of know that this is true. So I don't see any reason why this should be different for native apps. Like if people are willing to wait for multi-megabyte Photoshop download, I think they'll be willing to wait for that in the browser too. Okay, so a reasonable question at this point is it's like, okay, so if this is a whole new way of doing things, is this going to replace the way that things are done now? Is everybody going to be writing C++ or Rust in the future instead of HTML, CSS, and JavaScript? Is this the end of HTML and CSS and JavaScript? I don't think so, no. I think that basically this works for so many companies making so much money. I don't see why people would change just because there is another option. I mean, there actually, as we'll talk about later, there already are plenty of other options to HTML, CSS, and JavaScript, and they're still the most popular by far. I don't think WebAssembly is going to change that. I really think the main impact of WebAssembly is going to be that the definition of what is a web app gets bigger because it starts to encompass this additional thing that just was not popular back in 2006 when we were in the LAMP stack, this idea of a native application distributed through the browser. One particularly compelling example of this, I think, is games. Like imagine rendering this scene where people can walk around in CSS. That's just not happening. I mean, you need these like really low-level, high-performance technologies if you want to ship a game in the browser. That's only a thing that's become recently viable, like a plausible thing that you can do, but it actually is a plausible thing that you can do now. And I think there's going to be companies that are going to be taking advantage of that and start distributing their games through the browser first. So prediction number 2, I think WebAssembly is going to expand the web app pie. By the end of 2020, honestly, I don't think it's going to make much of a noticeable difference. I think the people who are working on these projects are going to be starting to work on them around now. But I think by the end of 2025, we'll start to see, okay, there actually is a new niche of like heavyweight web apps that are basically native apps distributed in the browser. Okay, part 3, packages. How many people recognize this logo? Shout it out. What is it? Bower, yes. So this was a competing package manager to NPM. They both coexisted for a while, and these days NPM won pretty convincingly. And now Bower usage is sort of dwindled off, like even more so than Perl. So a reasonable question to ask is like, okay, that happened to Bower. Could that also happen to NPM? Is there going to be something that replaces NPM in the future? Anyone recognize this logo? No, but interesting. This is Entropic. There was a talk given earlier this year. This was at JSConf Europe, the Economics of Open Source by CJ Silverio. And I don't want to steal her thunder. You should watch the talk and listen to the points that she's making. But essentially, she introduces Entropic, which is an alternative package manager. It's a bunch of people who worked at NPM and went on for various reasons that she explains in the talk to build a competing package manager. Also, we've seen competing CLIs, like Yarn is another way to access the NPM ecosystem. And now we're also starting to see competing backends, like GitHub Package Registry instead of like the NPM server ecosystem. Now, worth noting that, I mean, Yarn is a CLI which accesses the same server hardware, and GitHub Package Registry is sort of the opposite. I mean, it actually, on their website, they talk about, use the normal NPM CLI to access this ecosystem, just point it to a different URL rather than NPM servers. And so reasonable questions are like, okay, are these signs of NPM, going away? And I think at the end of the day, the fundamental idea of NPM is the real thing that people are making bets on. Whether or not it's Yarn or something else, I mean, really people are into the network effects of NPM, by which I mean the package.json file that says, here are all my dependencies, and they all have their dependencies specified in that way. Whether it's NPM servers or GitHub servers or something else, I think the important thing, the valuable thing, the thing that people can reasonably continue to bet on is that that ecosystem exists and all the network effects continue to persist. And I think they'll persist through continued problems. So we saw recently, not recently at this point, a couple years ago, LeftPad, where someone unpublished a package and broke a lot of people's workflows. They closed that off and said you can't unpublish packages anymore. That's all done. Earlier today, Chris talked about event stream, like a malicious package where someone successfully managed to get a hold of a package that was used by a lot of people and publish a malicious release. So Hillel Wayne wrote a really detailed write-up of the event stream incident. It's on his blog, and one of the things that he talks about is basically like there was no like one root cause where you can just close this off and it's fixed like there was with LeftPad. This is kind of a more systemic issue, and it's like not really going away anytime soon. This vulnerability is still there and is going to be there for the foreseeable future. And something that neither of those touched on is this. So if I were to install front-end dependencies by running a bash script like this, what's the difference between that npm install, which is the way that most people install front-end dependencies? Well, one difference is that when I run bash install.sh, it executes arbitrary code on your machine, which is a security concern. Whereas when you run npm install, it executes arbitrary code on your machine from thousands and thousands of packages. This is infinitely worse than running a bash script to like do install.sh, because it's all of your dependencies and all of their dependencies. Now you might be thinking, what do you mean I'm executing arbitrary code? Well, there's this thing called a post-install hook that any package can put in their package.json, and it will just execute arbitrary Node.js code, which is to say arbitrary code, on your machine every time that package gets installed. So if that's a virus, then cool, you just got a virus. And I think the main reason that this hasn't happened yet is just that it hasn't happened yet. Like we haven't had like the outbreak of the npm virus that someone spreads by using this. This has been disclosed since 2016. NPM wrote a whole blog post about like, hey, this is a thing that can happen to you. And they posted at the end of this blog post, like, if you want to disable this behavior and make it so that post-install scripts and pre-install scripts don't run this command, npm config set ignore scripts true. And then by default, they just won't run anymore. If you ask me, this probably ought to be the default. I've had this enabled for several years now, and although it's less convenient, there are various ergonomic issues with it, I still think it's better than being vulnerable to this virus. If you take nothing else away from this talk, please go home and run this command so that if there ever is a virus outbreak, you are not affected by it. Because I think this is going to happen. I don't see why it wouldn't happen now that there's like blood in the water and people have said, oh, you actually can publish malicious packages like event stream. Interesting. Okay. So in conclusion, though, do I think that NPM is going to go the way of Bower? I don't think so. I think NPM is here to stay. I think it might have financial troubles. GitHub will probably bail it out by saying, here's alternate servers. If it has more viruses and things like that, I think that it will survive because of those really strong network effects. But I mean, I still wish the Entropic folks all the best of luck. But if I'm making a prediction, I think that NPM ends up surviving whatever further problems come its way, or at least the ecosystem does. So I think by the end of 2020, I think there will be at least one more security incident. I think that seems like a fairly safe prediction. And by the end of 2025, I think there actually will have been a virus outbreak where someone successfully distributed a virus through an NPM package. And it will infect a lot of people's machines, but not those of us who have run this. Again, please run this. And don't be a victim of this. OK, which brings me to the final section, compile to JS. So back in the day, if you didn't want to write JavaScript in the browser, like 2006 era, you could write Java applets, which was awful. Or you could write Flash, which was a thing until it stopped being a thing. These days, the most popular ways to compile to JS is to actually compile a JS dialect to JS. So we talked about CoffeeScript. There's also Dart. Babel is like compile future JS to current JS. TypeScript compile a very slight superset of JS to JS. And Svelte, which is like trying to compile to more compact JS than some of the alternatives. All of these fundamentally are basically the same upsides and same downsides as JavaScript. I mean, they are JavaScript dialects. Any number of them could have the tagline, it's just JavaScript, and people would be like, yeah, OK, that's pretty much true. Even CoffeeScript had that tagline. TypeScript certainly does. But there are other options which are not JavaScript dialects, which actually have pretty different upsides and downsides of JavaScript. We've heard about a couple of them. Dave and Nolan talked about ClojureScript yesterday. We heard about ReasonML from Brian Phelps, and I'm here representing the Elm core team. All of these are going to have sort of fundamentally different experience than writing JavaScript. It feels like writing a different programming language because it is a different programming language. One thing that's different about these, that's from my experience, is that using a JS alternative is actually a cheat code for hiring good people. I actually don't know how we hired anyone at NoRedInk before we started using Elm, because pretty much everybody who applies these days, which is a lot of people, like we hired a head of talent and she commented, I have never seen an inbound pipeline this strong in my entire career. All the cover letters say Elm in them because the number of people who want to use Elm is a lot bigger than the proportion of companies that have taken the plunge and are willing to actually use it and then hire for it. So I think there's a misperception commonly. Like intuitively you might think, oh, it'll be hard to hire people. How will we possibly hire people? Like, man, I don't know how we hired anyone before Elm because it was way, way harder. So if you're wondering, like, why might I use something like this? I can certainly speak to my experience with Elm. I mean, I talked about, like, okay, it renders faster than the top JS frameworks, emits smaller bundles than the top JS frameworks. Also, no runtime exceptions. Like, it almost never crashes in practice. This is like our error logs. These are JavaScript errors. We've had like 60,000 plus since we started using Elm in 2015. Elm ones, it's not 0. It's just 0 pixels. Like, if I were to zoom all the way in, you could see, like, it has happened. It's not never, not literally never. But I mean, this is obviously not something we're thinking about. Generally speaking, if it compiles, it just works and then doesn't crash. It's pretty great. Also, there's a completely separate package ecosystem. So all the stuff I just said about NPM doesn't apply to Elm projects. Like, we have our own package ecosystem. It doesn't have post-install hooks or pre-install hooks. It's really fast and it's really nice. Another thing is the error messages. This is like a really common thing that people praise about Elm. So this is from the most recent release of Elm, which was last Monday. If you get a syntax error now, it reports it like this. Hey, I was parsing an import until I got stuck here. This is maybe if you tried to use JavaScript syntax for imports rather than Elm syntax, because Elm's a different programming language. It says, hey, I was expecting to see a module name next, like in these examples. It shows you like multiple code examples of like how to do it properly, and then it's like, okay, and they all start with capital letters. And by the way, go ahead and read this link if you want to learn more about it. Like, this is a pretty, I just picked this one kind of at random, but there's so many examples of this where, like, day to day writing Elm code, like, I just get this level of help from the compiler. It just feels really nice. Like I don't know how to describe it. The best way that I've found to describe the experience is maybe by contrasting it with my experiences whenever I find myself back in the JS ecosystem, like when I'm maintaining one of my Node CLIs or something. Like, just imagine if in your life building web UIs, like, things normally worked. Like, I don't know how else to say it, but like, I mean, normally when I'm writing JavaScript code, or like I'm installing a package, I'm like, this didn't work with it. Why didn't this work with this thing? Like, in Elm, I just install packages and they normally just work. Okay, whatever. And then I'm like going to upgrade a package. I'm like, wait, this used to work, but now it stopped working? Like, what's going on? Then I'm like Googling stuff, and then I'm like, okay, fine. And then I go back to Elm and I'm like, oh, everything works again. Nice, okay, cool. Everything is like this. Like, it compiles and it normally just works. Like, I haven't been able to express this feeling in any other way, just than like, whenever I go back, I'm just like, am I dumb? Like, what? How come I can't get anything to work anymore? But in Elm, it's just normal. Not 100% of the time, but normally things work out pretty well. And if that sounds interesting, you should check out the Elm website. And learn more. But I also know from experience giving Elm talks and stuff that a pretty small percentage of people in the audience will actually go and do that. Probably an even smaller percentage will actually run the npm config command, but I'm being realistic here. If I'm making predictions about the future, I know that this is a not JavaScript thing, and JavaScript rules the web, and I think that will continue. Like, at the end of the day, I really do think that the next big thing in the web is TypeScript. It's not going to be Elm. I don't think Elm is going to take over the world. I think TypeScript will. This graph will continue. But that doesn't mean that I necessarily am going to be getting on this train. Like, to me, I'm like, yeah, I think Elm is much nicer. I have no interest in that. And there are a lot of people who feel the same way, just not as many as feel that TypeScript is what they're going to go with. And that's fine. I mean, really, at the end of the day, again, the point of this is not to win popularity contests, like Perl had won the popularity contest. The point is to find a technology that you're happy with, and that you continue to be happy with over the next 5, 10 years, et cetera. I've been using Elm for about 5 years, and I definitely see myself using it for the next 5 years. It's something that I'm happy with and that I think is going to continue to age well. So my final prediction is that I think that JS alternatives stay niche, but that they age well. I think a lot of people who are betting on these technologies today are going to continue to be happy with those bets, so certainly with Elm. So by the end of 2020, I think they'll still be growing. We actually had 4 Elm conferences this year. Apparently, a lot of people I talked to didn't know that. But yeah, I'm still growing. But not as fast as TypeScript. TypeScript is taking over the world, which Elm is not, and that's fine. By the end of 2025, I think that they will have aged well, although, of course, TypeScript will have continued to grow and will, at that point, still be more popular. All right, so to summarize, started out by talking about the path of, I'll just choose boring technology and everything will be fine. Not necessarily. A lot of the times it's more about correctly predicting which technologies end up being something that you're happy with over the long haul. Talked about predicting is safer than following blindly, which can lead you into the same kind of situation we would have been in with Perl. Made a few predictions about TypeScript, WebAssembly, the web ecosystem, and compile to JS. I predict that TypeScript is going to take over the JS world. WebAssembly is going to expand the web app pie rather than replacing things. I think NPM is going to continue to have problems, but ultimately it's going to survive them. And finally, I think that the JS alternatives like Elm, ClojureScript, ReasonML, I think they're going to stay niche in terms of popularity, but that they're going to age well, and they're a good thing to bet on. So what will I do personally? Well, I think I made it pretty clear. I'm going to keep using Elm because I think it will continue to age well. Thanks very much.
Richard Feldman, you have so much energy. Thank you so much. This was a great talk to have as the last one, and we have some questions. Do you expect AI and machine learning to make leaps in popularity and development? What about pure robotics and automation?
That's a great question. So as far as popularity goes, I think that AI and ML already are trending that way. I think there's probably more to come, but I also think that if I were to compare it to TypeScript, I think TypeScript is underhyped relative to how far I think it's going to go. I think AI and ML are overhyped relative to how far I think they're going to go. I think the number of applications, the number of ways that they're going to be transformative, at least in the next decade, is not like, we're not going to be like singularity, we're here. Everyone's thinking their way through every problem and the machines just connect with our brains. I don't think we're going to get there in the next decade. Maybe eventually, but I don't think anytime soon. More than that, I think if you look at the demos of today of what AI and ML are doing, I think it's going to be variations on that, incremental improvements on that, not really earth-shattering stuff like a lot of people are predicting.
In your opinion, why Elm is not as popular as React? What is it missing to become more popular?
Yeah, number one reason that Elm is not as popular as React is that Elm is not JavaScript. I mean, that's literally it. If you're building anything that is not JavaScript, its popularity is going to be infinitesimal compared to JavaScript. The cultural momentum behind JavaScript is just absolutely massive. Any programming language that is not a JavaScript dialect, where the learning curve compared to JavaScript is anything significant, is going to be really big. And I think that's basically going to mean that I'm willing to go on record as saying I don't think that anything that is not a JavaScript dialect in the next 10 years is going to get anywhere near the popularity of anything that is fundamentally JavaScript. I think that's just how strong the momentum is. So again, but I think that's fine. You also need to be significantly different from JavaScript if you have any hope of being significantly better than JavaScript. And I think the delta between my JS experience and my Elm experience is as big as it is because it's different, and that also is why it's not ever going to be as popular.
All right, our apps scale to millions of customers and performance is critical. Elm doesn't support code splitting, though.
Yeah.
And is a deal breaker for our team's solution?
We'll keep going with that one. Yeah, sure. Yeah, so that's a great point. Please get in touch with me because basically the steps that we wanted to take were cool. First, let's make the bundle sizes really small with code splitting, and then we'll look at what are people's remaining problems in practice. Hey, I have this Elm app and it's too big because of X. And what we've heard from people who are actually building Elm apps is they're actually they're not too big anymore. We don't really want to go to all the trouble of code splitting, so never mind. But if that's you and you're hey, even if it were just 29 kilobytes, that's too big for me, or I'm going to have 1 million lines of code and it's going to be however much X that size, please come talk to me because we're trying to build features based on people's actual needs and use cases rather than just oh, code splitting, we should check that off because everyone's doing it. We want to actually solve the problem of page load times and bundle sizes rather than just checking features off a list. So yeah, come talk to me.
All right, last question on this stage for you. Do you think ECMA script will continue to be the dominant JS standard?
Yeah, so that's a really interesting question. I'm guessing where this is coming from is so there's ECMAScript, which is hey, this is how JavaScript should be, and then there's TypeScript, which is kind of becoming the default compiler. If I'm right, if my prediction's right and it ends up taking over, what happens if TypeScript says, hey, you know what, ECMAScript disagrees with us and we don't care. We're going to keep doing things the TypeScript way. This is certainly not what happened to CoffeeScript. CoffeeScript, ECMAScript ended up adopting some of CoffeeScript's stuff and then replaced it. So yeah, I think it's a totally valid question. I think that I don't have super high confidence in whether or not it will continue to be the dominant JS standard. I think if it's not, it will be specifically because ECMAScript and TypeScript clash, and TypeScript said, hey, look, we're not going to change. But I think it's probably more likely than not that if ECMAScript did clash with TypeScript in some way where TypeScript was yeah, we disagree about what's right here, I think TypeScript would eventually cave. I think that's more likely. I think it's pretty plausible that one thing I've heard people talk about is maybe ECMAScript will come up with a standard that says, hey, this is what types JavaScript is, and it'll probably be very close to TypeScript, but maybe there'll be some differences. I wouldn't be surprised if TypeScript said, okay, fine, we'll just get on board, and now TypeScript becomes the dominant compiler of the ECMAScript type system. So I think it's more likely than not, but I want to be honest that I don't have a super high level of confidence in that one way or the other.
All right, thank you so much. Everyone,
Thanks.
This was Richard Feldman.